We got to be to work before that.
Yeah.
Well, some of us have to be. Yeah, some of us have to be.
It says we're live.
I was thinking about starting to do that more. People are asking about that because we have people from Lincoln and Kansas City on the thing. Just it's kind of rough. Trying it out.
Good evening. Welcome to the November 2018 Omaha Live User Group. I'm John Larson. I'm a systems engineer with AIM.
Are you the system engineer with AIM?
I am the systems engineer with AIM.
That's not more impressive.
Oh, thank you. When I started, we had 3. Now there's 1.
Which 2? Get the work 3 men, get them pay 1.
They got replaced with bash scripts. Well, I don't know. Let's see. Did Ubuntu come out last meeting? 1810?
It did come out.
Okay.
Yeah, it was mentioned.
Yeah. Fedora 29 came out a week or so ago. Yeah. That's been fun so far. I've upgraded 1 machine and now DNF is broken. So it's living up to its name. Linus is back on the kernel mailing list. He's had his break.
Kinder, more loving.
Linus? Yes.
You ever seen the SQLite code of conduct? It's various Christian Bible passages saying, like, be kind to each other. And people are, to use the phrase, apocalyptic. I mean, he's had those in there since it began. It's like, now people are all angry about that because it's under public domain, so you can do that. I don't get that. And there's the whole thing about the AGPL coming down again. MongoDB changed their license, Redis changed their license, other modules and stuff.
Really?
Oh, yeah, some interesting stuff.
Well, as they say, things will roll. Either they're rocking and rolling or they're just rolling. One or the other.
They're bricking.
Bricking. I don't want to hear about bricks. not where I'm equipment. It's not. I've already got up at 3 this morning for a page. I don't want to have to do any more. So tonight, George Shinos is going to talk about do-it-yourself DCC command station.
John.
Yes.
Can I do one plug?
Yes, you can.
Thank you. Nebraska Surge got their joint security panel next Wednesday over lunchtime. It's going to be us, ISAC Omaha, DEFCON 402, and the ISC Squared Omaha guys. So it's down at Johnny's Cafe, 27L, RSVP, it's investor.org. It's a lot of fun. It's a panel with a bunch of people on it, including the former CSO of California. So
that's next Wednesday?
That's next Wednesday, yes. We're doing it the week before Thanksgiving.
So the 14th?
Yes, 14th.
That's
Thanksgiving.
That's 2 weeks from tomorrow.
No, 14th is next week.
It's the 6th tonight.
Oh my goodness.
Yeah.
I wish it was 2 weeks.
Wow.
We did it. We're doing it a week earlier than we normally do it because we didn't want to be right before Thanksgiving.
Yeah. My November 1st was spent mostly on a plane, so that's how I kind of missed the month.
Go to Hawaii.
I had no Halloween. It was weird. It's like, did this even happen this year? Apparently not. So, okay. I think I've stalled enough.
Okay. Well, about 2 weeks ago on a Saturday morning, I gave this presentation to the local NMRA, National Model Railroad Association group down in Papillion. And Matt was a new member. And when he found out he had to go out of town, he probably really couldn't think of much else and said, hey, could you do whatever it was you did last Saturday for these guys? Because it uses Linux and, you know, it's like, you know, could be of interest. Well, there's more everything else than there actually is. The Raspberry Pi runs Raspbian, and that's about as close to Linux content as we're going to get tonight. But we will talk a little bit about that. The interesting part is that one of the oldest hobbies around, model railroading, is really turning into something that's much more technically oriented than many people associate with the hobby. But model railroaders, if I went back and I started reading some of the old magazines about the hobby from the 30s and the 40s, and these guys were really kind of for consumer stuff on the cutting edge of technology ever since the hobby's been around. I mean, there were articles in there of how to wire your own, or how to wind your own transformers, how to, you know, especially through World War II, when all of the commercial companies were building military stuff. You know, this was all about how you can make whatever components you need yourself in your garage. And it was really kind of interesting. But I rearranged this a little bit so that you guys would have an idea of what problem we were trying to solve with this technical stuff, and added a little bit more problem definition in here just to give you a little chance of, you know, knowing what the hell I was talking about. You guys have all probably been in corporate training sessions where they talk about how you learn about something and where you are on the knowledge scale. And, you know, the basic level is unconscious incompetence. You know, that's where you know so little about something that you don't know what you don't know, and you really can get into trouble. And I've barely in this area, I've kind of moved up into that second level where I know enough to know that I don't know a lot of stuff. So, you know, in a few years, I may make it up to one of these higher levels. But the nice thing about that is generally, if you're one chapter ahead of everybody else that's listening to you talk, you know, you're usually doing pretty well. So a few notes that I added here to this presentation. It's on my website so that guys that are interested can download it. And these are just some things I learned after I gave the initial presentation, but we can worry about that some other time. Back in what is called the old days, most model railroads ran on direct current, okay? The left rail was positive, the right rail was ground. Okay, or the other way around. Didn't make any difference as long as you didn't get them crossed. Okay, and that was great. And you all probably remember that little transformer you had when you were a kid. And the higher you turned it to the right, farther you turned it to the right, the faster the little locomotive would go. Well, that was great until you wanted to run two trains on the same track. Okay, so back in those days, the common way to do that with DC, if you had two little controllers, you would break the track into blocks, and then each one of those blocks would go to a double pole, double throw switch, or a single pole, double throw switch, and you could assign that block to either one of those cabs, okay, either one of those controls. So if the guy on the left wanted to run a train, he'd flip that toggle switch to the left. If the guy on the right wanted to run the train in that little area, he would flip the switch to the right, okay? If you had three, you'd get like a rotary switch that had three sets of contacts on it, and as we go. So it worked, and for years, it was the real common way to do things. In real life, it looked more like this, and that's a really neat panel, actually, compared to a lot of them. Somewhere in the late 80s, or it had to be the late 80s when DCC got real popular.
Yeah,
right? Yeah.
Late 80s, early 90s.
I mean, there were several early attempts at multiple control systems, lots of different methods. Most of them were around for a few years, and then finally, the NMRA is the standards body for model railroading. They finally got together and said, okay, this is how we're going to do this. Any of you guys that want to make one of these, here's what the digital control signal needs to look like. So they defined this standard data packet, and instead of breaking up the rails into blocks, you would just run two control wires to the track, everything went through a single control system. I'll get a little more into detail in this in a minute. And through the rails got two jobs at that point. The rails supplied the power to run the motor, but on the rails, you always had whatever the maximum voltage was. Generally, it's 13, 14 volts now, okay? The reason that everything doesn't go flying around the track at full speed is that between the pickups and the motor is a little decoder that decodes this digital signal that rides atop that power signal, okay? So each one of the locomotives has a distinct address, and you can send speed commands, other commands, you know, the whole works. And part of what the NMRA did was they have this list of what those standard control variables are. Now, this is Harvey's control panel. It's a little more complex. And in addition to controlling the trains, everywhere there's a track switch that would go to the left or right. You could click on one of those, and it will also control accessories like that track switch. So you can do all of that remotely without that rat's nest of wires. He has a different rat's nest of wires, but that's a different story. So inside this locomotive is this decoder right here. That's what it looks like. That's called a mobile decoder because it goes in a locomotive and it's going to be going around the track. They're all different shapes and sizes of stationary decoders that control those accessories, okay? This tiny little one will control one switch. This slightly larger one, that's actually that one right there, will control actually a couple of amps for some of like the big LGB trains that you see outdoors and stuff like that. They draw a little bit more power. And then this is just another brand. It actually controls 8 accessories or 8 turnouts. So circling back a little bit, this is what one of these DCC systems looks like. One of the commercial systems looks like. So this is your command station. Okay, it's the brains of the whole works. And this is the throttle that you carry around to control the train. Okay, you've got speed controls up here, and then all kinds of controls like to enter a locomotive number, so you can attach this throttle to that locomotive, and you can control as many locomotives as you can fit on the track. Okay, and you can turn the lights on, all kinds of other stuff. And then this is the standard between that I showed you up here. This connection is standardized. Okay, this is the NMRA track bus. This connection between the throttle and this command station, that's proprietary. Every different vendor has his own little command language. So once you buy, this is an NCE system, for instance, you're kind of stuck in most cases with NCE throttles, okay? Harvey's got a lens system. Another one of our friends has a system from a company called Digitrax. There's several systems out there. And of course, I have my throttle, but when I take it over to Harvey's house, it would be useless because it's a different brand of system. So, you know, there's model railroaders all over the country, and quite a few of them are technically oriented. And what they did, and I don't know what the timing was on this, but I know it was at least 15 or 20 years ago. They said, all right, this is standardized. That's great. But I should be able to control any brand of command station from a computer or some other kind of device. And so a group of guys, quite a few guys, that spend lots and lots of time writing a piece of software called JMRI. That's the Java Model Railroad Interface, okay? So most of them develop with Apple computers, but since it's written in Java, you can, you know, run it anywhere, okay? Now, each one of the manufacturers still needs a little physical device to connect JMRI running on any kind of a computer to the digital command station, because like I say, they're expecting their proprietary commands to come into the command station. So Java does all the stuff in a universal language. Then there's a translator for each different brand that goes here. Okay. So along came cell phones, and, you know, 2 or 3 different guys wrote throttle apps that would run on a cell phone that would then wirelessly talk to JMRI, which would then talk to the digital command station. Okay. Now, here's the thing. With a few exceptions, a digital command station and a throttle, they're in the $300 to $500 price range. Okay. And throttles are $150, $250 a piece. Okay. So you're talking about, for most people, a significant amount of money. Okay. So JMRI got pretty popular because, you know, pretty much by that time, everybody had a cell phone. So, you know, you didn't have to pay anything for your throttle, because at least the basic version of the apps were free. And so a few years went by, and people are using old laptops that are hanging around, you know, and a lot of guys are still doing that. You know, it's one of those things where when you go into a guy's house and his railroad is running on an old XP computer, you know that hard drive is just waiting to die, you know, because it's been that long. Okay. So, you know, then along comes the educational efforts of the Raspberry Pi Foundation that makes a nice little computer for $35, and the what the heck is this called? Arduino. Thank you very much. I was thinking of other things. You know, the Arduino guys came along from Italy for educational purposes, and even if you buy one at full price, what are they, $20, something like that. So, you know, guys start doing a little bit of experimenting, and as it turns out, this will replace that JMRI computer very, very economically. And in addition, you know, since the newer versions of it have Wi-Fi built in, you know, you can get rid of this wireless access point, you know. And this, since we have the definition of what it's supposed to be, and it's a standard, then you can use the Arduino to generate the generate what is the expensive part right here of your digital command station. Okay. So why would you do this? Okay. You know, for a lot of guys, even the low cost systems are a couple of $100. Okay. So if you're willing to experiment just a little bit, you know, for just a few bucks, you can put together a system that really doesn't take a lot of actual physical putting together. You know, we're talking about a couple of wires and plugging on a shield. And for a small layout, this is going to work just fine. There are a few guys out there, you know, that are really interested in the hardware, and they've added lots of boosters and stuff like that and can run a pretty big layout with them. But honestly, I think that's kind of taking it a little bit too far. And then there's a lot of guys, they have a nice layout in their basement and they have that expensive command station, but they'll build a small project layout to demonstrate something, or just something that's going to be in another room, and they don't want to spend a lot of money. So, you know, it's a secondary thing. And honestly, I just did it since I'd read about it so many times. You know, it's like, well, all right, my grandson got me into his robotics hobby, and I had most of the stuff except for the one Arduino shield laying around. So it's like, well, let's give this a try and then see how it works. And, you know, some guys just like playing with stuff. So, you know, that's a good reason to do it. The Raspberry Pi part of it, and this probably is more of a sales pitch to the guys that are primarily model railroaders and don't really think too much about computers. But, you know, the nice thing about this is the stability. You know, when I go back to this machine, it never fails that I really just need to do something quick, and it's in the middle of updating its, you know, its operating system or some, you know, something. So this is not going to change unless you change it, okay? And reliability, you know, this is kind of what I was talking about. That old computer you're using is probably just waiting to die anyway, and then you're going to end up having to replace it. Simplicity, 9 times out of 10, if you're going to use a Windows computer for running JMRI and connect it to a command station of any type, you're going to have to download software drivers to talk to that particular brand of little translation card that I was talking about. And, you know, when I read the support groups, that and why does my COM port change every time I plug my cable in are the 2 biggest problems that people have. And, you know, first of all, the drivers are already loaded on this. It's not something you have to go digging around and download. And that's a difficult thing. You guys don't, I bet, understand how difficult that is for non-technical people. That's a real stumbling block. And the other thing I kind of, you know, this is just my own opinion, but a lot of guys will connect with JMRI. They'll use their cell phone to connect through their home network. And if you're going to make this your wireless access point, you don't have all your buddies coming over with their throttles and connecting to your home network. You know, you're just kind of like isolated on this little thing right here. And the nice thing, one thing I really like about it, you know, everything is on this SD card or micro SD card. So when I do decide to go to the next version of Raspbian or do a lot of changes, or I take this card out, I make all my changes on a different card. And if they don't work, I can just put the old card back in, you know. So from my standpoint, it's one of those things where I could do a backup from here, but that's just another time-consuming pain in the neck. It's just so much easier to pull that SD card out. And the JMRI software needs so little resources. It's just, even this is about 10 times overkill for whatever you're going to do with JMRI. And this is, again, where the low cost comes in. Connecting this to that doesn't really cost you anything but this little cable. For a lot of those little interface cards, they're going to cost you a minimum of $40, and some are up in the $100, $150, $200 range. So we're talking about saving a little bit of money. And here's just some comparisons of some different things on the market. That this, even if I bought everything, would run about $140. And then here's some comparison prices just for some other brands. So why wouldn't I do this? And one thing I didn't say, we talked about Windows and drivers and COM ports. It's actually even more difficult on an Apple. On a Mac, they hide so much stuff to keep you from making mistakes that you really do have to jump through a couple of undocumented hoops in order to get connected. So anyway, I'm not trying to trash any branded computer. It's just,
Is what it is.
yeah, it is what it is. Now, why wouldn't you do this? Now, there's a lot of model railroaders that they can just, I said this the other day. One of the guys called me up. He was using JMRI. He was having a difficulty using it on another computer. And I said, open a browser, and there's this pause. He says, what's a browser? I said, that big E thing on your computer. Click on that. And it's like, I'm not making fun of this guy. I used to work over at OPPD for years and years. And for a long time, the training department, the IT training department reported to me. And they had a giant poster on a wall that, you know, up in the corner, you have your dash and your square and your X, you know, to control your window, right? And I said to one of the trainers, I said, why? You know, why is this on the wall? She said, the people that come in here need that up there as a constant reminder. I can always refer to that to show them how to open and close a window or shrink a window or whatever, okay? And these aren't dumb people, okay? These are really smart people. this just isn't their focus.
Their environment that
Yeah.
they normally work in.
Yeah, they run rings around me in other areas, you know. So anyway, so there's a lot of people, they, you know, Raspbian might just be as nice as it is. It just might be that they're going to be unfamiliar and it's going to be different. It might be a stumbling block for them, and they just don't want to deal with it. There are some things, there are some layouts that require a little bit more sophistication than you have here, because there are a few limitations. And a lot of guys, you know, when I say solder this wire into this hole here, soldering is just this thing that is like
You're in the headlight look.
high tech stuff. They don't want anything to deal with. These are not commercial products, so there is no helpline to call. Okay, there's nobody to contact that has a vested interest in helping you. Okay, there's a lot of places out there to get help, but it's all volunteer, and maybe you just don't want to deal with that. And some guys just like the way the commercial throttles are laid out, you know, and they're willing to pay the money for it. And honestly, in the grand scheme of things, you might not be saving all that much money. You know, you're on basically what's a $200 to $300 purchase, you're saving maybe as much as $100. Okay, now that sounds like a lot, but over the long haul, when you start adding more and more things onto this purchase, you know, that $100 becomes a smaller and smaller percentage of the savings. So when you figure your labor and how much time you're going to have to be messing around with this, you know, this, maybe it's not a big, for you, it may or may not be a big deal.
How do you put a price tag on fun, though?
Oh yeah, that's the thing. That was the other thing. See, you and I, we'll sit there, Louis, and we'll look at this, and when something goes wrong, we look at that as an opportunity to have some fun, right? Well, you know, most of the guys just want to open it up and plug it in, and they don't want to deal with it, you know. So, you know, that you just got to know where you are and where you're coming from. So here's the other thing, okay? Now, when you buy one of these commercial systems, okay, at a minimum, you're going to get one of these throttles with every one of these commercial systems, okay? You're not going to get that with this. You have to use either a cell phone throttle, or you'll use one of the software throttles that come with JMRI, okay? And there are a lot of guys that really like that physical throttle. So if you don't like the cell phone apps, there are 2 or 3 options out there. ESU, a European company, makes this throttle, which is basically an Android cell phone without the phone, okay? And the Android app runs on this little screen right here, but you have that thing that the guys really love, which is a physical knob to turn, okay? And then there's 4 little buttons on the side here that you can assign. Those run about $240, okay? And then there's a new throttle, which is really neat, you know, that has lots of knobs. And sold out. Yeah, they're sold out. They sold out in 2 weeks.
What's the price now?
$580, and sold out in 2 weeks. And they're hand assembled. There's a company called Iowa Scaled Engineering. Some guys from one of the 2 Iowa colleges. I can't remember which one. Yeah, probably. And although their company is in Colorado now that they've graduated, but they custom make these in batches of about 100. There's only a couple of hundred of them out there right now. Yeah, they're $580, but they work real cool.
And they Bluetooth to the computer?
Okay, so the way they communicate, the throttle is actually $480, and then you get a $100 interface card. You only need one interface card for as many of the throttles as you want. They use XB, the XB protocol, to talk to their own little interface card, and then that interface card has a Raspberry Pi Zero on it that talks to the Wi-Fi on this. that part's a little, I don't know. I might not have done it that way, but that's the way it works. But they're cool anyway, and it's a toy. We don't have to worry about the amount of money we spend on our toys. We don't justify toys. Okay, that's just
My wife know that.
yeah. Well, that's a different problem. Okay, so all right, so that's the background. All right, so basically, what it boils down to, this can be replaced by about roughly $50 worth of stuff here. This is the command station. Okay. And this replaces the computer. Okay. So I'm not going to spend a lot of time on this. You guys know how to download software. Some of these slides are in here because it was a step-by-step presentation of how you would do this. What you really needed to know is there are two different motor shields. You guys are familiar with Arduinos and shields, right? Okay. So the Arduino can only put out about 500 to 600, maybe 700 milliamps. Okay. Well, that's not going to do anything for the motor control. Okay. You're going to very quickly, you would burn up your little Arduino pretty quickly. So you need one of the motor shields to get up into the half amp, full amp range with all the kind of like pretty noisy environment of the model railroad environment there. So there are two motor shields that the fellow who wrote the Arduino sketch a few years ago just directly support. Okay, one is the official Arduino motor shield, and it'll supply a couple of amps. The interesting thing about this, when I started looking around for this thing is completely sold out everywhere. Okay, they're like $20 from the official Arduino.cc website, but they're out of stock. And everywhere else I look, they're going for like 40 to $50 on eBay, which is just kind of ridiculous. I have a feeling what they're doing is they're coming out with a newer, upgraded board. That's why they're out of stock everywhere. The other one is this OLUG board, and the good thing about it is it'll supply 3 amps to the model railroad. The bad thing for a lot of guys is all of these little connectors and headers and all this stuff, they come in a bag and you got to solder them in place. That takes about 15 minutes. Not a big deal if you're comfortable soldering. But like I said, it scares a lot of guys away. I think it was $25. I got it someplace. I can't remember, maybe 30. Yeah, 30. I rounded up there. So if you go to the GitHub page, you'll see the wiring diagrams for the two different motor shields. Okay. And all it really boils down to the physical stuff that you have to do. There's a couple of solder pads on the bottom that you got to scrape off so that the power supply from the motor shield and the power supply from the Arduino don't talk to each other and make things too hot for one or the other. Okay. The other thing you need to do is you need to connect about 4 jumper wires. Okay. So that you can get the output of, well, the outputs just have to be on the right pins, and you need to put in some jumper wires to do that. So what you end up with, it needs its own power supply. The Arduino is going to be powered from the USB cable that connects to the Raspberry Pi, but you need your track power. So you need to, this is like $9, I think, on Amazon. So you get your DC, your power in. The Arduino and the motor shield do all of that standardized data packet stuff that you saw in that first screen, and then you output to the track. So this, I'll hook up right here. And this is our power. So this is your DC in. And you should see a couple of, yeah, you see a little blue light comes on. So that's half of it, okay? Now, by the way, Samsung must supply the lowest quality power brick for their TVs that could possibly be. When I looked on Amazon for this 14 volt 3 amp power supply, it was available from about 14 or 15 different sources, all, you know, fulfillment through Amazon. Every one of them said 14 volt 3 amp power supply replacement for Samsung model number such and such TV. And it's like, I've never seen any other replacement like that. So I'm just assuming it's something that a lot of people go through pretty quickly. So anyway, so now we've got, you know, maybe $50 to $70 in our command station over there. And this is just, I was just showing guys where they can download the software from the GitHub project. And, you know, you got to load the IDE, and you've got to compile the software, and you got to load it onto the Arduino. And that's kind of a big deal for guys that don't really do that. It's not really too tough for fourth graders that was designed for, but for, you know, a lot of guys our age that have never dealt with this stuff, downloading software and just the concept of having to compile something and everything can be, you know, something that you got to wrap your arms around. So we've replaced that $500 command station with a couple of little boards here, okay? And, you know, now we got to have a throttle somehow. So we're going to use JMRI to do that. Now, just a few things about buying a board, maybe putting it into a case, you know, that kind of stuff. Now, here's the deal. You've got it all put together, and now you need to load the software onto it. Now, you could go to the JMRI page, and they have a nice set of links for you that say, okay, here's where you download the current version of Raspbian. Here's where you download JMRI and load it on. Here's some code that you can edit a file, and it will turn the Wi-Fi into a Wi-Fi access point instead of just the normal way that it's configured at first. And there's 2 or 3 other things that you can do to get this and ready to go. And this is, again, kind of a stumbling block for quite a few people. There's a guy out there named Steve Todd that just loaded all the software, made it work, and so that you don't have to configure it for your particular brand of system, he put an auto execute script up front that just looks at the interface and tries to identify each one and figure out which brand it is, and just does all the configuration and everything for you. Then he took that image and he put it on your website and said, just download it, have a ball. You don't have to do anything. Just download Etcher and burn the image onto a, you know, onto your micro SD card. So there's still a little bit of that kind of stuff that you have to do, but all that configuration, you know, falderall, you don't have to do. And he supports almost all the systems that are out there. So we've got Steve Todd's system out here now. And what we're going to do is we're going to plug this into the USB port, and then the JMRI little computer needs its power. And so we'll plug him in. Now, the nice thing about it, the way Steve Todd configured it, he configured it so it's headless. So you don't need a monitor, you don't need a keyboard, you don't need anything. And we're going to wait a couple of minutes here and let it get going. And I've got one of those throttle apps loaded on this old iPhone. And as soon as it's not up yet.
So that iPhone doesn't have cellular service?
No, it's
You just,
it doesn't have a SIM card in it.
you just,
I just use it on Wi-Fi.
Yeah.
okay.
I have 3 or 4 old phones at home, and
Yeah, you can use an
I probably
iPod.
yeah,
Um,
iPad, iPod.
for the club that we're in, we have a similar Raspberry Pi running our system. And last Christmas, Amazon had their 7-inch Fire tablets on sale for $29. And so, half of the guys
Yeah.
bought those, and that's what they use for a throttle.
Yeah, it's a little big and bulky, but works great for the visually impaired. You know, as you get a little older.
Comment, future proof.
Yeah, future proof.
You'll grow into it.
Yeah.
Okay,
Yeah.
so now this is a big stumbling block, and what you actually have to do once this is all up and running, nothing's going to work until you turn on the track power. Okay, I don't know if you saw those little lights light up there, but it's just one of those things where nobody wrote that down anywhere, and in everybody's haste to get things running, it's just something they really overlook. So it's like probably the number 3 question on the support board. It's like, I hooked everything up and nothing works. So, it's like, did you turn the power on? Oh yeah, thanks.
Not plugging it in. You were talking.
Yeah. Okay, so this engine is number 1610. Okay, and so basically I put 1610 in here, and I go over and turn on the. Can you guys hear that?
Just barely.
Yeah.
There you go.
Make it loud. That's probably better. Okay. Okay. So now that's part of the digital command control. Well, let me turn that bell off because it'll drive me nuts. With regular straight DC, you can do some of that, but because you've got this digital signal going to the decoder, in addition to controlling the forward and backward speed, you can have as many different kinds of accessory little commands like that as you want. And it's kind of interesting to see what the different manufacturers do. Okay, I don't hear anything. I don't know if you can hear the brake squeal or not. Probably not. So the company that makes this particular brand of decoder, they pride themselves in how many recordings of different locomotive prime mover engines that are available. And so you can download whatever sound file that you want to make it a 4-cylinder, 6-cylinder, 8-cylinder, 12-cylinder locomotive, whether it's turbocharged or not. And, it just goes on from there. But the digital signal is what makes that all possible, just because you can control so many things. Now, unfortunately, when I gave this presentation to the NMRA guys, I had a couple of tracks. I had this nailed to a board and a couple of track switches that I could change directions and that. He called me like 2 days after I had taken all of that apart. And so you're seeing just a straight piece of track here. But these decoders, these are those stationary decoders that I was talking about. And you would have 2 wires coming from your power supply, and then the other 2 wires would go to whatever kind of a track switch that you would have. And you could send, I'm not sure if it's still set up for that. Yeah. Can you guys see that from there? See, there's 2 little red things that look like Ys right there. So basically, from this throttle, you can control all your switches. You can throw them back and forth from that. So again, because it's a digital signal, you just have a lot more things that you can do with a lot less wiring than you used to have to do with DC.
It's all essentially one big bus.
Yeah, it's
all
one
addressable item.
right. Everything's addressable. So this, did I go past it? I think I went past it. Well, the problem with using the Raspberry Pi is it's a multitasking operating system, so you're going to have other stuff getting in the way and of your actual command program. The Raspberry, or excuse me, the Arduino, the timing on that digital signal is precise, so they use the built-in timer functions of the Arduino, and you know, it's not really a computer, it's a microcontroller, and it's got one task in its mind, and that's what it's going to do, and nothing's going to interrupt it. So that's why the Arduino makes such a good controller, but you need a human interface, you know, and that's where the JMRI comes in, you know. And you know, that big control panel of Harvey's that I showed you, that's all part of JMRI, and you build those control panels, and there is so much stuff in JMRI that I'm not even scratching the surface. I mean, it's really just for fun, go to jmri.org and just read the first page, and you'll see all the different things that it does. And they're not all necessarily related to each other. At any rate, I think the address range for locomotives, most guys these days use whatever number is painted on the side so that it'll help them remember what address they programmed it to. But the range is like from 1 to 10,000 you can assign addresses. Then the separate address space is for the accessory decoders. I can't remember. I think it's like 1 to 2,000, somewhere in that range. Might be higher than that. And then there's yet another address range that does not overlap for controlling signals. Okay, so if you had signals on your layout, each one of those signal heads has its own address, and you send it. That's part of also what JMRI does. You know, if you got signals that are like green over red, yellow over red, flashing red, all that kind of stuff, those are separate commands that you send to the signal head, and each signal head has an address. So let me get past burning things with Etcher here. You don't really care about that. Okay, now, when Todd built that image, he was really nice to start up a server so you could log into it with VNC if you wanted to. Let me see if, yeah, or I'm already connected. So you don't have to do this. You could plug an HDMI cable into it or use a keyboard, but yeah, I must not have been.
Just said it was okay.
Oh yeah, I'm not connected. I purposely did not check the box that said connect automatically, because when I'm home, I don't want it to do this. We'll give it a second here.
Now, do they all, since it's hard coded, it's all going to come up with the same last name?
Well, no, you can edit the file to make it whatever SSID and password that you want. I just didn't on this because I didn't have any reason to. There we go. Okay, so this is what JMRI looks like. And so you can see I'm connected with George's iPhone, and Locomotive 1610 is being controlled by me right now. And, you know, this is where you build those control panels. Harvey uses a module of JMRI called operations, which has the inventory of all of his rolling stock and all of his destinations, and it'll create a switch list for him to go out and say, okay, deliver this car to this place, deliver this car to this place, pick up one from over here, you know. And I'm not kidding. It gets,
That's impressive.
yeah.
And then in the yard, if you got like 10 tracks in the yard, it'll tell you what track to put that on. And then when this train rolls in, it'll tell you what track to pull that car to put on that train to go to that destination. Yeah. Well, a lot of guys still like the car cards.
Yeah.
This is so easy. You don't have to think about it. I mean, you just push the button, the computer randomly throws it at where it needs to be. And you don't have a big stack of cards to stick trying to, yeah. Because some people will drop it, and then there you are picking it all up. And, yeah.
Yeah. Model railroading was role-playing games before, way before people thought of role-playing games. You know? So anyway, that's kind of it in a nutshell. Like I said, I'm not getting deeply into the operating system or any of that kind of stuff. You know, the idea here is there was a problem. It's part of a hobby, you know, and what started out as a way to save a little bit of money and for the electronic guys to have a little bit of fun putting stuff together, kind of really blossomed when, you know, the Raspberry Pi came around for such a cheap price, you know. And thank God for all the open source stuff out there, because there are a couple of commercial versions of pieces of what JMRI does, and they're all in the 600 range. And, you know, this is free. These guys just out there, you know, download it, do what you want to do with it. You know, that's it. So if you guys have any questions? Yes, sir.
A couple of questions about the receiver in the locomotive.
Oh, yeah.
Okay, so first of all, are there specific receivers that just are non-proprietary, and they just, or do they all just use that?
Well, okay. So the physical hardware and the software that's running on the decoder, that's all proprietary. There's like half a dozen different manufacturers that make those decoders, okay? But that digital data packet that's coming in over the rails is specified by the NMRA. And the NMRA, so to customize a decoder, there's a zillion configuration variables, okay? I mean, it's just a big table of 16-bit values, okay? And so, so on this guy, there's the engine sound, the brake sound, the bell, the air compressor sound, and a couple of others that I don't remember right now. So there's a CV that's a master volume control. Then there's an individual volume control for each one of those things. And so you adjust the volume of those by changing those CV values, okay? The first, I think, maybe 100 or 150 of those CVs are standardized, kind of, okay? But when sound came along, the NMRA hadn't specified any CVs to standardize on for controlling sound, okay? So every manufacturer added like 300 or 400 more CVs any way they wanted to, you know, and so they're not necessarily standardized. Once you get above that, I think it's like 150 or something like that. And one of the things that's interesting, like if you go down and you see a railroad train go by, you very seldom see one with a single engine on the front, okay? Most of them have 2, 3, or more locomotives, okay? So every time you go out and you buy a locomotive, it runs a little bit differently than another one, okay? But you know, because you want to emulate what they do in the real world. You know, guys want to run 2 or 3 or 4 locomotives together at the beginning of the train. So there are 28 CVs that are called the speed table, okay? And this throttle, even though it looks like it's a sliding scale, it really only has 28 speed steps, 1 through 28, okay? So one of the things you do with JMRI is you go in and you adjust each one of those values. Let's say it's speed step 1, you want your locomotive to run at 1 mile an hour, okay? So you set this engine at speed step 1 to whatever the value between 1 and 256 is to make it run 1 mile an hour at speed step 1. And you go all the way up to speed step 28. This one's maximum speed is 17 miles an hour, okay? So at speed step 28, I set the CV value to get 17 miles an hour. And then in the middle, you know, I set each one so that it gradually increases, right? Now, I might want to connect this or with another brand of engine that's geared differently, but I want them to run together, okay? So I go to that locomotive's decoder where it has a 28-step speed table, and I adjust those 1 through 28. I put the values in there so that it will run at the same speed as this one. So I can have all kinds of different locomotives all connected together, running at the same time, and it's not a big deal. Back in the old days with DC, you were out of luck, okay? I mean, if you had 2 of exactly the same brand that were made exactly the same way, maybe you lucked out and they worked together. Or some guys actually went in and they changed the gearing of locomotives. But primarily in DC, if you saw a couple of locomotives running together, they actually sold dummy locomotives that didn't have a motor in it. They had everything but the motor, so you could just have the guy in front pulling that dead-headed thing with no motor in it, but it looked like there were 2 locomotives on the front, you know.
Okay, second question.
Sure, okay, I went way farther than your first question. But
Locomotives. They're probably Atlas and Athens that are probably 25, 30 years old.
so you can buy decoders to put in them.
Decoders, you know, as the hobby move forward to the point where the rolling stock is really tied to the locomotives and tied up to this kind of a system.
Well, the fundamental mechanical part isn't really. I mean, they're a lot nicer now that they actually run in both directions. It's, you know, they work real well now. Where, you know, in the 70s when I was doing this, if you had a locomotive that ran forwards and backwards relatively decently, you were pretty happy with it, right? But that was the other thing that, you know, you can take one of those older engines, you know, you clean all the old grease out of it, and you make sure the gears are good and all that kind of stuff. So you can go buy a decoder for about 45 bucks or so. That's a motor control decoder. And one of the nice things about it, the decoder in between speed signals that it's sending to the motor, it's measuring the back EMF coming back from the motor, so that if the motor is working a little bit harder, then they'll adjust the speed down to keep it run, or they adjust the command going, speed command going to the motor, they adjust it down so that it maintains that constant speed, okay? So you might have an older locomotive that actually on DCC runs a whole lot better because of the motor control that's built into the decoder than it ever ran on DC. And some of them, all of them, you have to isolate the motor from the frame. And sometimes it's just way more trouble than it's worth, you know, to do that. And a lot of guys that have been in it for a long, long time, they'll have some of their engines, they just don't bother to convert because, you know, basically by the time you take them all apart and put them back together again, there isn't a way to shoehorn that decoder in there without machining away some of that lead weight, you know, that keeps it from falling off the track and lets it pull more than 2 cars, you know, and that kind of thing. So yeah, the answer is probably you can convert them, but some of them you might not want too. You know, the HO engines, there's usually, I mean, they got a nice sound card and a speaker into that thing, you know. This was originally DC. Well, you know how they say DCC ready? Yeah, and what that means is they don't have the decoder in it, but there's a place to plug it in, you know. I bought this when I got back into the hobby in 2012, and really at that time it didn't have room for a sound decoder and a speaker. But in those few years, the decoders are a lot smaller now, and you know, this technology, because of the design they put in the speakers, to shoehorn speakers into this, that's got a cell phone speaker in it, is what's generating that noise right now. So it's just a little rectangular thing about size smaller than a postage stamp, and only about so thick. Yeah. Now, N scale is a different story. N scale, generally, if it wasn't designed for a decoder, it's pretty tough to fit one in. Everybody else is going to go home and dig their old Lionel trains out of their mom's basement. Well, that's kind of all I have. Go ahead.
Since nobody else is asking,
Yeah.
one more question.
Yeah.
So you were talking about this is for this kind of setup with and small or possibly medium layouts. How does if you're scaling stuff out?
Oh, what makes small? What makes medium? What makes large? If you ask 4 guys that, you'd get 4 different answers. But yeah, Harvey's layout is a bit bigger than this room. It fills a couple of big rooms in this basement. You know, my layout is a small shut, and basically it would fit on this table right here. Okay. The magazines kind of says small is something that fits in a room and you can still use the room for other stuff. Okay. Medium is like a whole bedroom full of stuff that takes over the whole room. And then somewhere bigger than that is medium and large, you know. Well, you know, you never know.
Yes, you're right.
You never know.
So does JMRI work well at large?
Oh yeah, Harvey had an issue. He uses a combination of this and some proprietary radio throttles. Okay, his basement is L-shaped, and the radio throttles would never reach over into the far corner, but the JMRI stuff, you know, that uses Wi-Fi signals, worked just fine. Now, since then, he's got a repeater for his radio cabs, and it worked great over in that area. But you know, he's got a bunch of the old radio throttles, and he's got a bunch of old iPads, and you know, all kinds of stuff. When guys come over, if they don't want to use their own phone, they can just grab one off the cell phone. We're both in a group called Omaha N-Track, where our layout is made up of modules that are slightly smaller than these tables, but when you put it all together, it's like, I think, 16 feet wide and 26 feet long, and it's a big rectangular thing. We were at the SAC Museum a couple of weeks ago, and I wanted to test how far the Wi-Fi on the Raspberry Pi would work. So I just, you know, we were at the end, the room we were at was at the end of a big long hallway. So, you know, I just started honking the horn and walking down the hall until the horn didn't work anymore. You know, and I was about somewhere between 60 and 70 feet away, and it was working fine, you know. And I just didn't have any more hallways, so I couldn't run it further. I think Wi-Fi is what, 100 feet, 200 feet, depending upon. all kinds of stuff. Yeah. So.
And the competitor boards, like the Tinker board,
Yeah.
it has an external antenna attachment.
Yeah. Yeah.
So you could get more distance.
Now, this is one thing I didn't say. If you're into this, okay, and you like electronics and you like playing with it, feel free to use any motor shield that you want, okay? Just remember, the pins may not be in the same place, okay? They're like the Adafruit motor shield doesn't have any current feedback, okay? So it doesn't work at all, okay? So if you're not, if you, and this is kind of what my message was to the model railroad guys, if all you're going to do is put this together and you really don't want to make this be a little sub hobby, buy exactly the components that are in the instructions. There's an interesting conversation taking place right now. There's one of the fellows down in Australia that does a lot of exhibition layouts, and he bought some Arduino lookalikes basically from some Chinese source for about $5 a piece, and the oscillators are slightly off, so the timers that are so dependent on that digital signal to get things exactly the right, the right length. He was just having a devil of a time, and it's like, all right, I'm just going to use these for something else, and and then he bought some official Unos.
Yeah.
So I see one here.
I moved the car up underneath the park because I was running the tunnel.
Oh, okay.
So it's closer to get to the car.
Any other questions? I think we're, do you have any input? You work with JMRI and stuff with the
I'll
club.
tell you, once you start using it, it's so much fun, and it's so much easier. But it doesn't help that when we have a running session, somebody parks a tank car in front of the dock that should have a box car, or a box car into the. That stuff still happens, and you still have people. So every time you get done, you got to run a report to make sure the cars are where they belong. Can't fix stupid, so to speak. So no matter how simple it is, the number's right there, and it tells you what to go with it.
So it's replicating a real yard.
Yeah.
Oh yeah.
So it's not good.
But it's a lot of fun. It's a lot easier to use that because then the guy can just check off, what you got, and
you don't have to shuffle all the cards. And I don't know anybody that hasn't dropped a whole handful of cards in the middle and had to go sort them all out before they could.
And it keeps track of it for you. It regulates down through the towns, like town 1, town 2, town 3, town 4. It sets the cars up inside of there. So when you're running down, excuse me. So when you're running down through there, you can pull the car off at the front of the train like it should be instead of searching through it.
Sensors that know where you're looking at.
You can fix it that way if you want.
You said you set up programming.
Oh, that's part of JMRI, but that it's kind of like a funnel. Okay, it's like fewer and fewer guys get into that.
And
well, the computer will set up. You got like car 1 through 20 on the back of the locomotive. So your first town A, will take like the first 4 or 5 cars, and then when you pick up them cars at town A, you put them in the back. And
but you do all that yourself.
Yeah,
that's all done manually.
Like set up your schedule for the day. You watch.
You can. There are guys that do that. Yeah, there are guys that do that. In fact, in Europe, it's much more common to have everything run automatically and sit back and watch it.
We have a guy in the club that's working on that kind of thing.
Yeah.
He's doing his, but he definitely doing on.
He uses that $500 software.
Yeah.
Well, there's typically. Well, now remember that first one I showed you with DC, where you would break up the track into blocks.
Yeah.
Okay. So if you're going to do that type of stuff, well, you don't have to run the train yourself, okay? But if you want to know where the train is on the track, it's not for the purpose of power, but you break the track up into those isolated blocks, and then there's a little detector that says, oh, there's a train in this block right now, and that feeds it back to JMRI, so JMRI can know where the locomotives are.
On that.
Those sensors are for each block. What's a BD? They're
Yeah,
20 bucks maybe, something like that. What they are is they're just little coils, and you have a feeder wire going to that track, and you loop it through that coil, and it senses when the current goes through.
On that layout,
Right, and it sends it. Yeah, basically it just flips a bit. And then you've got another little box that it hooks up to that takes all of those inputs and sends it back to JMRI as an encoded signal. Oh, those are wired. Yeah. You end up with that rat's nest again. Yeah. Oh no, you don't. You wouldn't have. Today, you wouldn't have Bluetooth on all of those sensors. It would just end up being too expensive. But each one of them has a wire that goes back to whatever you're going to do. Oh yeah, but you might have 100 watts in the lamp. Wires.
you know how he showed you how that layout is on mine? I've got a program so when the dispatcher says he's here, the little train actually moves from area to area to area.
A little visual?
Yeah, a little visual train.
Okay.
And if you do it like you're saying, if you're doing it like what you're saying, it would automatically do it where the dispatcher wouldn't have to do it itself.
And if there was somebody in front of him, it would just stop him so they wouldn't collide.
Not so much, I don't want to spend the money on the toys.
Yeah.
I want to help other people with their toys.
Well, wander in on a Saturday, first Saturday of the month to an NMRA meeting and just kind of meet some of the guys. It's at the Papillion Library. Now, we probably won't meet again until January. I can't.
Side rooms, those two side rooms?
Yeah. There's one of the big meeting rooms. The one that's by the emergency exit in the back is where we usually are.
The NMRA. What is NMRA.com?
I'm not sure. They were.
It might be org.
And they were. Give me your email address and I'll make sure you're on the newsletter so that it'll say the next meeting. You don't? Okay. All right. Well, Google like Western Heritage Division NMRA, and that'll take you to the webpage that shows the schedule.
Oh, thank you very, very, very much.
There's another, if you're interested in operations, another website, OS Omaha, talks about some of the layouts that are in town. There's like
we're going to be doing that next. In fact, tomorrow we got a meeting.
Oh, you're part of the.
Yeah.
Your layout's one of the layouts on the. I was going to say, just looking at the web page, it has pictures of
OSOmaha.com
of the various layouts in town that are going to be a part of this, and you have people come in from all over the country.
Oh man, all over.
How much does that cost then, or do they just sign up? Or
they sign up. I don't know how if they take people from Omaha or not, because it's kind of from out of town.
It's for because you do for local people on your own,
right? Yeah.
But it's a nice website because it shows pictures of all the different kinds of layouts that are in basements around town, and right now there's like 11 or 12.
Yeah, probably. There's quite a few now, right now.
To be determined.
OSOmaha.com,
I think, yeah.
Yeah, I'm there. It says 2019 OS Omaha Weekend Circuit TV.
Yeah, it's like second weekend of June is when they're going to have it. They were going to have it first weekend of June, and now they made it second weekend of June, and so now I'm not going to be able to do it just Saturday.
Really?
Yeah.
You got something else going on?
Yeah, we'd already planned it because they said they were going to do it first weekend of June. So I thought, now they changed it.
Right now, if you're interested in just kind of seeing how the signaling and everything works, there's a free model railroading magazine called Model Railroad Hobbyist, and it's mrhmag.com. And they're in the second part now of a multi-part journey of a guy that went through signaling and detection on his own layout. It started last month, so you go to last month's issue first, and then on to this month's. And
what George is really trying to say, if you've got the money, you can do whatever you want to do.
Yeah.
I don't have a whole lot of money to spend. I've already done that most of my life. That's why I have 20 Raspberry Pis. But I like, you said there's people who can't solder, there's people who can't put this together.
Oh, yeah,
like
yeah.
And it's like, I can help them, and I enjoy watching their investment.
Right.
That's why I hang out with Harvey.
It's almost as rewarding. What's that mag address?
mrhmag.com. Yeah, or just Google Model Railroad Hobbyist, and it'll come up. I can't think of anything else off the top of my head. Any other questions? Okay. It's too late to vote by 1 minute, so if you haven't voted, you're out of luck.
No, that's tough.
Yeah, I was going to say it said that all night long.
Yeah.
Oh, okay. You got
It's an atomic clock with the batteries dead.
You got 11 minutes to get
It's
to
not,
the poll.
it's not atomic powered. So.
Oh yeah, yeah.
So that they can't switch the TV on.
Quicker to replace those.
Yeah, you're right. Yeah.
Let's give a round of applause for George. Very fascinating. Thank you.
All right.
So, coming up on November 15th, AIM has their yearly tech celebration. It's over at Founders 19, which is at 1915 Jackson, 2 blocks down there. We have our award winners this year, all up on, should be up on the webpage soon. I guess they are.
Do they still do the Guru of the Year?
They did, but we have Tech Innovator. I think is what they've now kind of changed that name.
I was the second to the last Guru of the Year.
Yeah.
After, well, the year after, I can't remember the guy that got that, and then that must have been either when they changed it or
they decoupled the banquet dinner from Infotech and made it a separate event.
Yes.
And then that's when they kind of changed how the categories and things like that.
I got a big hunk of glass on my mantle saying Guru of the Year some year. I don't remember what year it was. I'm retired now, so those details.
But you can register for tickets. I don't think it costs anything. Yeah, it's like 5:30 to 8:30.
Probably cost your employer something.
Yeah. Well, I know that I have been voluntold to do some things.
Voluntold.
So, I'll probably be doing some filming or pictures like I normally do. But next month is holiday spectacular, if you want to call it spectacular. And some Raspberry Pi talking. I might have something built by then, I hope. We'll see. I saw an interesting project on my trip to Hawaii. So I'm going to do something close to it, but not the same.
You say RetroPie is going to be on?
No, it's not RetroPie. No. There was a group of students at University of Hawaii Hilo that built particulate sensors that they deployed around the island during the lava flow this past spring. So to help people know when they need to get away from such ill health effect items, so SO2 and things like that. Also saw a project called Raspberry Shake. It's seismographs using Raspberry Pis, so you can deploy your own seismograph. It's pretty neat. They can get like self-contained cases that has the unit with the Raspberry Pi, and you can deploy them. It's very fascinating. Pretty cool. So, see you next month. We'll say goodbye to our TV folks. Goodbye, folks.